the night sky looks peaceful. Stars hang quietly above us like tiny dots of light. For thousands of years, humans looked up and felt wonder. Today, we have the most powerful telescopes ever built. We have satellites orbiting Earth. And yet, the more we look, the more we realize how little we actually understand. Right now, astronomers all over the world are staring at data that makes no sense. They are finding things that our best textbooks cannot explain. These are not small gaps in our knowledge. These are enormous, gaping holes in our understanding of reality itself. Here are the 7 biggest unsolved mysteries in astronomy right now. In late 2019, something alarming happened in the night sky. Betelgeuse, one of the brightest stars visible from Earth, started to fade. Not slightly. It lost more than 2/3 of its visible brightness in just a few months. Astronomers immediately pointed their telescopes at it. For a star this large, this kind of dramatic dimming usually means only one thing: an imminent explosion. Betelgeuse is a red supergiant star roughly 700 light-years from Earth. It is so enormous that if you placed it where our Sun is, it would swallow Mercury, Venus, Earth, and Mars completely. Stars this size end their lives in a catastrophic explosion called a supernova. For a few terrifying weeks, it seemed like that moment had arrived. Scientists calculated that if Betelgeuse exploded, it would outshine the full moon and be visible in broad daylight. Then, slowly, the star began to brighten again. But that was when the real mystery began. Analysis showed that Betelgeuse had released a massive burst of hot gas from its surface. That gas cooled, formed a cloud of dark dust, and blocked its light from reaching us. Simple enough. But no one can explain what caused that enormous gas ejection in the first place. The internal mechanics that drove Betelgeuse to violently throw off a piece of itself remain completely unknown. Astronomers have now confirmed it is pulsing in ways that match no existing model of how red supergiant stars are supposed to behave. We cannot predict what it will do next. We cannot say when it will explode. Every single second, invisible particles are hitting the top of Earth's atmosphere at speeds so close to the speed of light that the difference is almost impossible to measure. These are cosmic rays. Most of them are ordinary and well understood. But occasionally, something very different arrives. A particle carrying energy so extreme that physicists gave it a nickname. They call it the "oh my god" particle. The first one was detected in 1991 over Utah. It was a single proton moving at 99.9999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 of the speed of light. The energy inside that one microscopic particle was equal to a baseball thrown at full speed. Not from an explosion. Just one proton. Since then, dozens more of these ultra-high energy cosmic rays have been detected. And the mystery behind all of them is the same. Nothing we know of in the universe should be able to accelerate a particle to these energies. The most powerful natural accelerators we know are supermassive black holes and gamma-ray bursts. But when astronomers trace the paths of these particles backward through space, they do not point clearly at any known source. The particles arrive from random directions without any pattern. Their true origin is invisible to us. Somewhere in the universe, an engine of almost unimaginable power is flinging particles directly at our planet. We do not know what that engine is. We have no confirmed theory. And every new detection only deepens the mystery. You may have heard that most of the universe is made of dark matter and dark energy. But here is something almost nobody talks about outside of astronomy conferences. We are also missing a massive amount of perfectly ordinary, normal matter. The kind made of protons and neutrons. The stuff that makes up stars, planets, and your own body. Scientists call this baryonic matter. Based on careful measurements of the early universe, astronomers can calculate exactly how much baryonic matter the universe should contain. But when they count up everything they can actually observe, every star, every gas cloud, every galaxy, they find only about half of what the numbers predict. The other half cannot be found anywhere. For decades this was called the missing baryon problem, one of the most embarrassing gaps in cosmology. Then in 2017 and 2018, two independent teams found a clue. Using data from fast radio bursts, they detected a faint signal in the empty space between galaxies. This suggested the missing matter might be hiding in enormous, nearly invisible threads of warm gas stretching between galaxy clusters. Called the warm-hot intergalactic medium, these webs of gas are so faint that telescopes had been looking straight through them for years. But even with this discovery, astronomers cannot confirm that all the missing matter lives there. The measurements are difficult. The data is incomplete. And the fact that we cannot account for half of all normal matter in the universe should strike you as deeply extraordinary. A galaxy is not a permanent, static object. It lives and grows. For billions of years, a galaxy pulls in gas from its surroundings, compresses it under gravity, and ignites it into new stars. Our own Milky Way is currently producing around 3 new stars every year. This process of star birth is called star formation. And in a healthy galaxy, it never stops. But astronomers have found entire galaxies that simply switched off. These are massive, dead galaxies that stopped forming new stars billions of years ago. No new light. No new stellar nurseries. Just old, fading stars slowly burning out into darkness. And when astronomers study them, they find no obvious reason for the shutdown. The galaxy has not run out of gas. It has not been destroyed by a collision. It simply went quiet. Scientists call this galaxy quenching and believe it is one of the most important unsolved problems in astronomy because it shapes the large-scale structure of the entire universe. 2 main suspects exist. The first is the supermassive black hole at the center of every large galaxy. When it feeds actively, it releases jets of incredibly hot energy that can heat surrounding gas so violently that new stars can never form. The second suspect is the galaxy cluster environment itself, which can strip a galaxy of its gas supply through gravitational pressure. Both mechanisms are real and have been observed. But astronomers cannot agree on which one is responsible in most cases, or whether some third unknown process is doing the killing. The murderer of galaxies has not been identified. When a massive star dies in a supernova explosion, it leaves behind one of the most extreme objects in the known universe: a neutron star. These objects pack more than 1.5 times the mass of our entire Sun into a ball only 20 kilometers across. A single teaspoon of neutron star material would weigh approximately 1 billion tons on Earth. The gravity at its surface is 200 billion times stronger than what you feel standing on this planet right now. But here is what makes neutron stars truly mysterious. We have absolutely no idea what is happening inside them. On the surface, the situation is extreme but somewhat understood. Neutrons packed tightly together under enormous pressure. But as you move deeper inward, the density reaches levels no laboratory on Earth has ever come close to recreating. At those depths, our equations break down completely. The laws of physics we use in every lab and particle accelerator stop giving reliable answers. Some physicists believe that at the very center, matter transforms into something never observed anywhere. A state called quark matter, where the building blocks of neutrons dissolve into smaller components and flow freely. Others believe the core contains strange matter, a completely unknown phase of existence that some theories suggest would be the most stable form of matter possible in the universe. We cannot reach inside a neutron star to check any of this. Our telescopes can only observe the surface. And our physics cannot tell us what waits in the deepest interior. The inside of a neutron star is a sealed box no technology can open. For nearly a century, astronomers have known that the universe is expanding. Every galaxy is moving away from every other galaxy. Space itself is stretching outward in all directions. The rate of this expansion is captured in a single number called the Hubble constant. Getting this number right is one of the most important goals in all of modern science. It tells us the age of the universe, its size, and its ultimate fate. 2 completely independent methods exist for measuring it. The first looks back at the faint glow of light left over from the Big Bang itself, the cosmic microwave background. Satellites have measured this ancient light with extraordinary precision. Their result is a Hubble constant of approximately 67 kilometers per second per megaparsec. The second method uses actual objects in the modern universe. Astronomers measure pulsing stars called Cepheid variables, then use those to calibrate distances to exploding stars called Type 1a supernovae far across the cosmos. Their result is approximately 73 kilometers per second per megaparsec. That 6-unit difference sounds small. It is not. Both measurements have been checked and rechecked by independent teams using different instruments and different techniques. Both results keep coming back exactly the same. The two methods agree perfectly with themselves. They simply do not agree with each other. This disagreement has now crossed the 5 sigma threshold. In physics, 5 sigma means the chance of a random error is less than 1 in 3.5 million. This is not a measurement mistake. Something is genuinely wrong with our model of the universe, and it is hiding inside that 6-unit gap. Everything we have discussed so far assumes one silent, unchallenged thing: that the universe we can observe is the complete story. It is not. The light from the most distant objects we can ever see has been traveling toward us for nearly 14 billion years. That is the edge of our observable universe. Not because space ends there, but because light from beyond that boundary simply has not had enough time to reach us yet. Beyond that horizon, space continues. But how far? In what shape? Measurements of the cosmic microwave background tell us the universe appears geometrically flat. Parallel lines across the cosmos would theoretically never meet. But flat does not mean finite. A flat universe could still be infinite, stretching without any boundary forever. Or it could wrap around on itself in a shape so enormous that its curvature is too gentle for us to detect with any current instrument. Some physicists have proposed the universe is shaped like a cosmic torus, a donut shape on an unimaginable scale, where traveling far enough in one direction would bring you back to where you started. Others argue it is a 3-dimensional sphere of incomprehensible size. We cannot test any of these ideas directly because we cannot see beyond our observational horizon. We are like fish inside a small dark pond trying to figure out the shape of the entire ocean from the few drops of water immediately around us. The instruments we would need do not yet exist. The true shape, the true size, and the true nature of this universe we call home remains the deepest and most beautiful unsolved mystery in all of astronomy right now.